Nakamana Pisai. All right, so in this video, we've got 3 virtual machines running. We have a Windows Server 2016, Kali Linux 2018.4, and Windows Server 2019. So we are going to run Nessus from Kali Linux and scan the network which all 3 of these machines are on. They're all 3 on the same network. It's this NAT network, testnet, which I set up in VirtualBox. And all 3 of them are on the same network. It is a 192.168.1.0/24 network. We can see that right here. Here's testnet. This is the network I set up. 192.168.1.0/24. So by default, all the virtual machines in VirtualBox are on a 10.0.2 network. So to put them all on the same network, you need to create a additional NAT network. So in the background here, this is the Kali machine. So let's go ahead and open this up, and we're going to run Nessus first. So let's go ahead and maximize this. So Nessus is already installed on here, Nessus Home. So I'm going to do etc init.d Nessus d start. And then we're going to go to our browser and browse to the loopback address port 8834. Nessus should be updated, so it should not take long to update the plugins. When you first set it up, it takes a really long time to update the plugins, or if you take a long time before you update it again. Well, let's see. Is it coming up? So here comes Firefox. It's just taking some time. So I'm going to go to HTTPS localhost 8834. Localhost is the same thing as 127.0.0. whatever. Is still initializing these plugins. So we'll give it a few seconds. I'll pause the video. We'll come back. Hopefully this doesn't take too long to come up. Okay, so now that we're logged on to Nessus, we're gonna delete. I'll delete this scan here. So we're going to do a new scan against our subnet that has the 2 other machines on it. We'll do an advanced scan here. And the subnet we just showed you in VirtualBox is 192.168.1.0/24. So that's the subnet we're going to scan if this ever comes up. Here we go. So our name is, we'll just call it 192.168.1/24 scan against local subnet, and we are using Nessus Home here. This is just for a demonstration. So what we're going to scan is 192.168.1.0/24, which is the same as 192.168.1.0/255.255.0, 24 bits in the mask. All right, so that's really all we need to set up. We could set up credentials if you wanted to connect to the Windows machine and do a credential scan, or SSH for the Linux machine. We could also do a compliance check. We're not going to do that. And plugins, right now, we have all the plugins enabled, so we're just kind of playing it safe. We'll go ahead and click on Enable All, but they should all be enabled. And we will ping the host here. We'll use a few different ports. We could change these as well if we wanted to. Like for port scanning, we could change the port range to do all ports if we wanted to. We'll leave it at the default for now. We'll go back here, and I didn't mean to go back, sorry. We'll go back to advanced scan, and 192.168.1.0/24 subnet. We don't have to put a description there. Again, 192.168.1.0/24. And I think that's all we said. We already checked all the plugins, make sure they're all enabled. So we'll click on save at the bottom here. And now we can click on the play button, which launches the scan. And while the scan is running, we can get a status here. So it shows it's running. You can click on it. Looks like we got some information against 1.4. And we can kind of figure out what 1.4 is maybe by the information. So 1.4, I imagine, is our self, since we have a netstat connection. So we can check that real quick as this is running. So let's go to a terminal window and ifconfig, and we are 1.4, which makes sense. We are not doing a credentialed scan, so it doesn't make sense to get netstat information from any other machines. So let's go back to the host. So we found, let's see, 1, 2, 3, 4, 5 hosts. 1.1, 1.4, which is ourselves, 1.2, 1.6, and 1.5. Kind of interesting. We've got a medium here on 1.1. DNS server cache remote, or snooping remote info disclosure. So 1.1, we can check out what that is. It should give us some more information here. Let's go back. 1.1, got 6 informationals. So let's take a look at the OS identification. It says it's a Kyocera printer. It's kind of interesting because that certainly is not a printer. That just goes to show you you should not always trust your Nessus results. Let's look at the ports that are open. So it looks like 53 TCP is open. That's for DNS. And let's go back here. So we'll let this continue to run. We can go back to scan, and it's still running. It looks like we've got 4%. It kind of gives you a rough idea. 4% done for 1.5, 4% for 1.6. And let's take a look at what these other machines are while this is running, just so you have an idea what we're scanning. So this, we were just looking at this Kali Linux 2018.4. We've also got a Windows Server 2016 and a 2019 Windows Server. So this is the 2016 server, it looks like. We'll log on to this one, and we'll also log on to the 2019. So, all right, Maverick is the domain admin account. We'll sure we'll get the updates. So let's do ifconfig. So this is .5. So the 2016 server is .5, and let's check out the 2019 server. The 2019 server Little Bub is also a domain admin. The 2019 server is, let's see here. All right, here we go. So we'll just go to PowerShell and we'll do a ipconfig if this ever comes up. So this one is 1.6, and let's do ipconfig/all. The default gateway is 1.1 and the DHCP server is 1.3. So there's only 3 machines on this network. There is 1.6, this machine. There is 1.5, this machine. And there is 1.4, the Kali machine. So 1.2 is VirtualBox, and so is 1.1, and so is 1.3. So let's take a look at what 1.3 has a low finding DHCP server. So that is the DHCP server running on VirtualBox. And there's the MAC address, and let's see if it actually identified the MAC address. and it says PCS System Technique. So that's not the doesn't say the VirtualBox MAC address, but that's okay. Got a few mediums here, 1.2, SSL, self-signed cert. So let this run, but this is basically how Nessus runs on these three systems. We're still running here. We have 98% of this one is still running. You can also look at the vulnerabilities and sort by vulnerabilities. But Nessus is it's a good idea to run Nessus on your home network periodically to check how your home network is doing. We actually found a couple criticals here on 1.5. Let's see what 1.5 has. 1.5 says there's a critical vulnerability of MS17010, which is Eternal Blue. It's kind of interesting. 1.5 was the 2016 server, I believe. There it is right there. So it has a vulnerability to Eternal Blue, which means we should be able to exploit that. So while this is running, we'll just try the exploit of Eternal Blue. So we will go to another terminal window here. And we'll make this a little bit bigger, but this is the basically the hacking methodology. You have to identify a vulnerability first. So we'll do MSF console. And again, we found that on 1.5. So yeah, so MSF console, whatever comes up. This is the Metasploit framework console. Well, that's coming up. Let's see what else we have. Only one critical. This one also has 10 medium, which is kind of interesting. But it's 99% done. So our results are pretty much done. So we only have a couple criticals to exploit here, potentially. We've also got SMB version 1. So now that we have Metasploit up, let's just do a search for MS10-17-010. See what pops up. So this is a good way to search for any vulnerabilities, and we notice that a few things pop up here. I can make this a little bit smaller. So we have a few exploits here. We have an Auxilary Scanner, but we have some exploits. This one will tell us if it's vulnerable. So let's try that real quick. So let's do a use auxiliary. I'll just paste it, copy and paste it. So copy this, paste it here, and we'll do a show options, and we'll set the R host to be the target, which is 192.168.1.5, I believe. Let me just double check that here real quick. 1.5 right there. That is the one, the critical. And let's just go ahead and run that, see if anything pops up. It says this is just a test to see if it's vulnerable. It says the host is likely vulnerable to MS17010. It tells us what it's running. So now we know it's 64-bit. It says it's vulnerable. It's Windows Server 2016. We already got that from Nessus, but we have a better understanding now. So let's do that search again we did previously and look for the exploits that do a match, have a match. So this one, average, normal. Let's try this PS exec one here, MS Eternal Blue. And what you can do also is info on the exploit to see what it works against. So let's say you don't know what these do. Let's try this first one here. That's Auxilary Scanner. Let's try this one. Info against the exploit. And let's scroll back up. So I just did info against that exploit. So this exploit just called Windows SMB MS17_100 Eternal Blue only works against, if we scroll down here, it says the available targets are Windows 7 and Server 2008 R2. So that exploit will not work because previously we saw when we ran the scanner that it is Windows Server 2016. So that did not work. So let's do a search again on, that's not what I meant to do. So we tried the first one, which runs, this one runs against Windows 7 and 2018. Let's try this next one here. Let's do the info on it. This one actually tells you it runs against Win 8 already in the title. So let's try this one here. Let's do an info on this one. This is the only one we have left. So info, and I'll paste that there. And it says, if you scroll up, there's options that it works against available targets, automatic, PowerShell, native upload, and MOF upload. Runs against both x86 and x64. It gives you some more information here. So this one will automatically select the target. So let's go ahead and try this exploit. And sometimes when you try these exploits, they don't always work. So I'm going to use the exploit. I'm going to paste it here. I'm going to use this, and we're going to do show options. We have to set the rhost, I'm sure. Set rhost to be 192.168.1.5. Whoop, can't type today. If we don't know what payload we want to choose, we could just do a tab. All right, looks like that's not coming back. So let's do set payload, and let's just hit tab. 208 possibilities. So I don't know why Windows didn't fill in. So we've got Windows, load library, exec, DLL inject, reverse TCP. We can try that one. And the whole idea is if we get a reverse shell, that means we connect to the target. The target, we deliver this payload to the target, and the payload is ran, and the target connects back to us. So it looks like the conversation originated from the target. So let's try this one here. Oh, my autocomplete didn't work because I had a slash in front of Windows earlier. Sorry about that. There we go. Now we need to show options for the payload, because you have to set options for the payload in addition to the exploit. So the two options we have are localhost, lhost, and lport. So the lhost is the machine we want the payload to come back to. That will be this machine. 192.168.1.4. Let's just do an ifconfig and make sure this is correct. That's correct. And we're going to set the L port to something besides 4444. That's kind of a noobish. We'll do 443. And we'll do a show options just to double check them. So there's our host. There's our information here. And we're doing this payload right here. So go ahead and run this exploit. And it looks like the following options failed to validate DLL. So I need to specify which DLL to inject in. Yes. The local path to the reflective DLL to upload. So let's change this payload here. I don't use this payload very often. So let's change the payload, which you can just do set payload, and we'll choose a different one here, Windows, and hit tab there. Yep. So let's do interpreter payload, which typically works. So we do a reverse TCP interpreter payload right there. I'm going to copy that. Put here. I'm going to paste that there. And we'll do a show options again. We have to set these options again. So they're still the same. Lport and lhost are the same. So let's go ahead and run this one. Looks like it may be working. So it looks like it chose the PowerShell as the target for the exploit. Sometimes you have to run these payloads a few times for them to work. So that one says no session created. Let's try it again. No guarantee it will work. Sometimes you have to try it like 3 or 4 times. We did validate this one was vulnerable. So the exploit should work. Let's try our exploit here to reload the module. Oh, it looks like we've got a shell there finally. Okay. Over here it said we had session 1 and session 2. So let's try session -I, sessions -I1. Nothing there. Nothing there. So it looks like that session didn't work. So let's try to run this again. Whoop. What probably happened is the Windows Defender caught the session and killed it. So let's go. So we were able to exploit it, but Defender caught that. So let's go back over here and let's look at the 2016 machine we were trying to exploit, which is right here. And if Defender caught it, we should see a message. And our payload would have been quarantined. So let's go to Defender. Here's Windows Defender. Looks like open Windows Defender. Looks like it's turned off, so probably wouldn't have detected it. So let's do a check here. These were from a couple days ago, so wonder why it is not working. Let's do one more check. Okay, failed to load client portion of STI. It's kind of interesting because we actually got a session open, but then session 4 failed to load client script. So session 4 worked, but then failed to load the script. So let's try a different payload. Sometimes you have to mess around the payload here. Computer's being slow. Okay, Windows, and sure. So let's try a normal shell. Sometimes just a normal shell will work, such as this PowerShell right here. We can take Meterpreter out of the loop here. Copy that. Paste it here. So it's a little bit of troubleshooting live per se, and we'll show the options again, and we'll run that. The options look fine. It said you don't have to put any modules there. Required is no. So let's see if we get a shell. We got a shell before, but it stopped working. No session created. Let's try our exploit. So close. No session created again. We'll try it one more time. If this doesn't work, we'll move on. Nothing. No session created. Interesting. All right. So we'll let's try one more. You have to be persistent with penetration testing. So let's do a set payload, and we'll see what other options we have here. I hit tab twice. We're just waiting on it to come back. It's slow for some reason. There we go. Okay, so we will try a generic reverse TCP. This one almost always works. So if this one doesn't work, I'll be very surprised. It doesn't give us the ability to do as much as we can with the other types of shells, but this shell almost always works, like 99, well, at least for me, like 99% of the time, I would say. So let's do a show options again, just to validate. Okay, and we'll do a run. Oh, Command Shell 5 open. I told you it always works. We'll see if it stays open though. All right, so we're on Windows system. So finally, after multiple tries, we got a shell. We have a Windows shell though, so it's not quite as cool as a Meterpreter shell, but we are on the target system, which was .5, and there's .5. So I can do whatever I want on that system. At this point, we could upload Mimikatz and dump the RAM, etc. So that's basically how exploitation works. Once we found a vulnerability, typically with a critical vulnerability, such as what we found here with Nessus, that means we're able to exploit that system. That means we're able to exploit the system and take it over. That's pretty much what critical vulnerabilities allow you to do. And as you can see here, if I go back to the one, we just exploited 17010 remote code execution. So that's what we did. We used an exploit that took advantage of this vulnerability, then ran our code, which was the shell that gave us the reverse shell to the Windows target. All right, hopefully you liked this video. I was just trying to tie the Nessus assessment to an actual exploit, and I let it go here through some of these trial and errors, because realistically in a pen test, the first exploit may not work. You've got to be persistent, and you see here I didn't change anything, and Defender wasn't even able. We just tried several different payloads with the same exploit, and it took I think our fourth payload before it actually worked, and that payload just gave us a Windows shell. So we could have tried a reverse Meterpreter payload or one of these other payloads here to give us more functionality. So you have to kind of keep working through the payloads. This one here is just a fun payload. You shouldn't use this operationally, but all it does is say pwned through the microphone in the target system. So if you have any questions or comments, etc., leave it beneath the video. Hopefully you like this video and you will subscribe to our channel. All right, talk to you later.